And then we're also going to learn how to identify the leads of a transistor that we can't find the part number on. But not only identify the leads, but identify if it's an NPN or a PNP. So we know the transistor is going to have 3 leads. And which one's going to be the emitter, which is going to be the base, and which is going to be the collector. So I've got 3 leads coming out of the bottom of the transistor, which is going to be, so I've got a TO22 sitting in front of me, right? And I'm trying to check if it's good or bad. And then, of course, it comes up. Some of them have a little tab that comes in like that. And then it's got a hole there where we can mount it into our screw. And then it's got 3, we call them pins, or 3 leads coming out the bottom. Which one's the emitter, which one's the collector, and which one's the base? We could use it, but all we're trying to do is check to see if the transistor is good or bad. We should be able to figure out which one. You're right. I could look up the data sheet, but to look up the data sheet, that means I've got to have what? I got to have internet access, right? You understand? And then I got to go and figure out. Then I type in the part number up there. You know, I type so TIP 41. You know, so I could do that. But now, if I don't have a data sheet book available to me, then I need to be able to figure this out, right? You understand? First of all, if we do know the leads, how would we check that? So the one we're going to deal with is a TO92 package, and we're going to deal with 2. It's got 3 leads coming out of it. They're vertical. They're in line with each other. The one we're going to deal with is a 2N 3904, and we're going to deal with a 2N 3906. This is an NPN, and this is a PNP. And if we looked up the data sheets, this right here would be the emitter, this would be the base, and this would be the collector. So if you're looking at the flight side, the emitter's on the left. Okay. But I want to check, and I'm concerned, and I think it might be bad. How do I check this? Well, we're eventually going to do middle to collector. Well, I know it's an NPN. I know where the base is. So I'm going to get my ohm meter, and I'm going to put it on the diode scale. And then I'm going to come over here. My base is supposed to be positive, so I'm going to take my red lead and put it right there. Red lead right there. And then I'm going to take my black lead and touch it right there. That's a PN junction, guys. It's silicon, so what should it measure? Now, we don't ever say 0.7. It's going to measure what? Approximately 0.7. Then what I'm going to do is I'm going to lead my black lead along, right? You understand? And then I'm going to take I'm going to lead the red lead along. And then I'm going to come over here and do what? Move my black lead over to this side right there. It's a PN junction. What's it supposed to measure? Approximately 0.7. Okay. Then what I'm going to do is I'm going to take my lead and take it off the base, and I'm going to move it over to collector to emitter. And it don't make any difference which way you hook that up. Collector to emitter. What should it measure there? Good, overload. So now we've assured that it's working, right? And then what we do is we'll come over here and swap this around. And I'll take my black lead and put it on the base. So you need to check these things every way, guys. So I'll take my black lead and put it on the base, and then I'll go right there. It should measure overload, right? And then I'll move my black lead over the other way. It should measure overload. So what we've done is we not only check to make sure it's 7/10 when it's forward bias, but it's also blocking when it's what? Reverse bias. And that's the way we check a transistor. with a diode scale. Now, let's take away this. Let's say I didn't know what it was. And a 2N3906 is a PNP. So what we'll do is we'll start off with your black lead on the base, right? You understand? And then go on both sides. And then you go across collector to emitter, make sure it measures overload, and then reverse bias the base to emitter junction to make sure you get an overload on that way. So that way you confirm that the transistor is good, right? Very fast, not hard at all. The only part is these leads on the bottom of this transistor, and this upsets me too, is these are solid wires. And what happens to solid wires when you bend them a few times? They break. So when they mount these in their circuit boards, they'll twist these leads all around. And what I want you to do on your circuit board is I want you to put these things in 3 consecutive holes, just like that. And then wire into them, right? You understand? Don't try to make the transistor come to your resistor. Make the resistor come to the transistor, right? You understand? And you say, well, that's really close together. I can't get my meter over there, and that bothers me too. You got these big old resistors out here, and these big old resistors out here, this nice chunk of metal right there, and you try to get to the base of the transistor. You don't have to get to the base. All you got to get to is a common wire going to the base. And you're right, you can't hardly get your leads down in there without creating a short circuit. So let's say I have a transistor here, and the part numbers wore off of it, or it didn't have a part number. You bought it through Jamico, through their 500 transistor bulk package thing that they got. And you got a 3-lead device in there, and it's supposed to be transistors because that's what you bought it as. So Jamico sells bulk transistors, and you can just buy a ton of them. And usually they don't have part numbers on them. So how would we do this with my meter? Well, we don't know. It's a it might be a voltage regulator, right? So just because it checks bad all the way don't mean it. It just might mean it's not a transistor, right? And hopefully, if it's got a part, if we don't know what it is, then we'll just throw it away. If it don't have the part number on it, but if it does, if it checks like a transistor, then we would say, okay, we might be able to use it. So you got 2 leads on your meter. What you do, guys, is you just choose a random lead. So I'd come over and you choose a random side. I mean, I would come over here and do this, and then I would come over here and put it on the diode scale, right? You understand? And then I would just take a random lead. So let's say we take our black lead right there. And then I come over here and take my red lead, and then let me do this in red so it gets recorded. I take my red lead. In the first place, I'll come over and put it right there. I'll check my reading. If it measures 0.7 of a volt, one of those leads has got to be the base, right? You understand? Okay. If it measures nothing, then I'll take my red lead and I'll move it right there. If it measures nothing both ways, it means I've reverse biased everything, right? You understand? So what would I do then? Well, I'll take my red lead and use it as my common lead. So I'll come over here and I will take my red lead. I still got red. No, I got it on race. And so I would take my red lead and put it right there. Then I would do what? I would take my black lead and touch it there, and red lead, and then move it over there. If you don't measure 0.7 of a volt, you're going to measure 0.7 of a volt either the first shot or the what? The second shot. If you don't measure 0.7 of a volt on one of those other leads, it means it's not either not a transistor or it's bad, right? You understand that? Okay. So what I would do now, let's say I got 0.7 of a volt measurement between this lead and that lead. It measured 0.7 or approximately 0.7. What does that tell me? One of those leads have to be the base. But since I touched this one, I got, right? You understand? this can't be the base, because if it was the base, then these other two, I would have got 7/10 of a vote between those two. But I didn't. I didn't get a 7/10 of a vote right there, right? You understand? So what does that mean? So I got 7/10 of a vote right here, but I got nothing right there. Well, it means this guy right here has got to be the what? It's got to be the base. And what's on it? My negative, right? You understand? So I know right off the bat now it's a PNP. Y'all see that? You understand that? Yes or no? So if this is the base, right, you understand, then what I would do is I would come over here and I would figure out which one is the emitter and which is one's the collector. So what I do now is I take my black lead and move it over to the one that I feel is pretty confident is the base, right? And then what I'll do is I'll take my red lead, and I'm fixing to tell you something you won't ever find in a book, except maybe one that I wrote. I would touch it right here and take that measurement. Let's say it measures 0.758. And then I move it over here, and these are never going to measure the same. And this measures 0.732. Which one would you think would be the emitter? So this is identifying the emitter, guys. The emitter is heavily doped, so it's going to have a bigger breakover voltage than the collector. The collector is moderately doped, so this guy right here is going to be the emitter right there. Every time, every time. You won't find that in the book. The emitter base junction will always have a higher VF than the base collector junction, always. So now I know it's a what? It's an NTN. And I know which one of these leads, what. So let's say this might have been the emitter, it might have been the collector, depending on which one of them I read first. So I should have said this guy right here measures that. And now I not only know it's an NPN, I also know which is the emitter and which is the collector. So how did we do that? So this is in the lab, guys. We got two transistors that's got pieces of tape on them, and they're numbered. One of them's a TO22 case, one of them's a TO92 case. And you're supposed to figure out which is the emitter. You first figure out what type it is, either NPN or PNP, and then you got to figure out which leads are which. So just knowing it's an NPN don't mean anything, right? Because any lead could be the base, any lead could be the emitter, and any lead could be the conductor. Why can't you look it up on, if you got the, and Milton was right, if you got a part number on there, and you got access to the internet, then what can you do? You can look at the data sheet. And Jamico has a really, really good, that's usually where I go. It's got a really good database of data sheets. You just type in the part number, it'll bring up their part number, but that right down below it, it'll say, do I still have their site up? No. Of course, you could just type it in, but what you're going to get is a bunch of things up. A lot of them want you to pay for the data sheets. You have to watch out for those. But Jamico Electronics, www.jameco.com. And this is where we get most of our parts from. And then I can come up here and type in a 2N3904. There it is right there. You see I searched for it before. And in fact, just about all the data sheets. And you can see how much these things cost. So the smallest unit you could buy is a group of 10. And how much does a group of 10 cost? 9 cents. So if you want a hobby around, then this would be the route to go. Then we could just click on the device, and then right here, see right here, data sheet. And of course, all their data sheets start with this, but it don't belong to them. It belongs to the company that makes it. So normally, what we do, we have a Acrobat Writer, which gives us the ability to skip off, drop off pages that we don't like. So if you look at my data sheet, it looks, wow, good gracious, it looks exactly like that. So that's the way to go, guys. I mean, like you said, but you got to have what? Yeah, internet access. Used to, and I wish I could find that book. It was Motorola book. They put out a bunch of solid state devices, and they had all the transistors and SCRs. That dang book was that thick, and it had all the data sheets in there, right? You understand? They don't make those hardly anymore. You can still get them, but normally if we know the part number, we just do what? Yeah, just use the internet, and it's amazing. Really saves us a lot of bookshelf space. So we had all these data sheets. I wish I could find those. I mean, we had a group of 16 data sheets, books that covered all these different devices, and that's what we had to go look up. So are you okay? You don't want to look at that again? Okay, so what's step one? Right, but once we got it set up correct, right? Choose the what? Lead, yeah, right. And then it's up to you what you want to start off with. You can start off with your positive lead, or you can start off with your negative lead. What you have to understand is when you got that sucker on ohms, you got a power source there, right? There's not much power source. So let's say I come up here and I take my meter on the watt scale, no scale, and then it's up to you. I just how I feel that day. Choose a lead. So let's say I come up here and choose this lead right here. And then what would I do? I usually choose one of the outside leads, and what I do is you got to get your meter in there, guys, but we don't want to bend this guy back too much. So what I do is I usually take the center lead and bend it back a little bit, so I can do what? So I can hold the middle, my leads on those leads. But we don't want to really bend it back, right? You understand? Because the more we bend it back, the more stress we're going to put it when we try to straighten it back up. Then what would I do? I would take my black and I would touch it on that side, and I would touch it on that side. If I measure 7/10 of a volt both ways, guys, I've done what? It's an NPN transistor, and I found my transistor. If I measure 7/10 of a volt on one of them, that means that one is going to be the base, right? You understand? That one is going to be the base, right? So I'd put it over there. Then I would take the lead that's on it. I would leave it alone. I would take the other lead and touch the two leads just to verify, right? You understand? I found the base. If I measure overload on both of them, then I swap my polarities. I would take what if I started off with the red lead on my random lead. I wouldn't choose another random lead, right? You understand? I would take my black lead and put it on there, and then I would touch the other two leads. And you're going to find 7/10 of a volt on the. If you don't get it on the first, you're going to do what? Get it on the second. If you get 7/10 of a volt both ways, then it's an NPN transistor, right? You understand, because we're using the positive, and you're through. If you get 7/10 of a volt on one of them, on one of them, that's the base. You'll move your reference to the base, and then figure out which one has the highest reading. Whichever one has the highest reading is the what? Is the emitter. So you can identify. You can identify the gain of the transistor. So you have no idea what the beta is. You have no idea what the breakover voltages is, but at least you know what type of transistor it is. And it might work in your circuit or it might not, but at least it has a chance. So we don't know the beta and we don't know the breakover voltages. A little TL92 should be greater than 50 volts, so we should be pretty good in a 5-volt circuit or a 12-volt circuit. So, what do y'all think? What did I do with my transistors? I have to figure it. We got a cage kind of like that. So the next lab we're gonna do, guys, is we're gonna let y'all do what? What? Okay, y'all can go ahead and do that, and then we'll do this. I would like. Okay, we're okay. I said I would like to probably do this while it's fresh on your mind. Well, let's go to lab.